Hello everyone. Today I'm here to explain a very important concept of infinite series. In this video, I'm going to introduce D'Alembert's ratio test. In the previous video, I have explained Cauchy's root test. If you are watching my video first time and if you have not subscribed my channel yet, subscribe this channel. Also press the bell button to get more updates of videos which I'm going to upload in this YouTube channel. Also, if you like this video, don't forget to give the like button in the YouTube channel. Let me explain what is D'Alembert's ratio test first. If sigma un, that is series, is a series of positive terms, and if limit n tends to infinity, un plus 1 by un is L, where L is a finite quantity, then sigma un is, that means first we have to find limit of un plus 1 divided by un whenever n tends to infinity, and we denote that limit as L. And if it is equal to L, then sigma un is convergent whenever L is less than 1. It is divergent when L is greater than 1. And this test fails here whenever L is equal to 1. So initially we have to find limit n tends to infinity un plus 1 by un, and that value whatever we are getting here, finite value, depends on that value we decide whether given series is convergent, divergent, or if L is equal to 1, test fails here. We have to go for another test. So let me explain this test with the help of some examples. First problem, discuss the nature of the series x by 1 into 2 plus x square by 2 into 3 plus 3x cube by 3 into 4 plus etc. So here series is given. First we have to write this in summation form. So sigma un. So first what is un? How we can write un here? Look at the terms of the given series. First term, numerator we have x, denominator 1 into 2. Second term, numerator x square. Similarly, third term, numerator x cube. So nth term numerator obviously x power n. And denominator, first term it is 1 into 2. Second term 2 into 3. Third term 3 into 4. So obviously nth term denominator should be n into n plus 1. So un is equal to x power n by n into n plus 1. Therefore un plus 1. So to write un plus 1, it is just enough to replace n by n plus 1 in the un. So we get un plus 1 as x power n plus 1 divided by n plus 1 into n plus 2. Now un plus 1 divided by un plus 1 divided by un can be written. Here this un plus 1 is x power n plus 1 divided by n plus 1 into n plus 2 divided by un. Since un is x power n into x power n divided by n into n plus 1. So we are dividing ratios here. So we write the reciprocal. So that is multiplied with the reciprocal of the ratio, that is n into n plus 1 by x power n. Now cancel the common term. Here we have x power n plus 1. Here we have x power n. So numerator x power n cancel and x power 1 remains in the numerator. And second numerator we have n into n plus 1. First denominator we have n plus 1 into n plus 2. So n plus 1 get cancelled. Simplified we get n into x divided by n plus 2. Now apply the limit as n tends to infinity. That is limit n tends to infinity un plus 1 divided by un. This un plus 1 by un we already simplified. So limit n tends to infinity n by n plus 2 into x. Here n in the denominator let me take out. So we get 1 plus 2 by n. and that n cancel with the numerator n. So we write 1 by 1 plus 2 by n as limit n tends to infinity into x. When we give limit for numerator, limit of 1 is 1, limit of denominator is, that is limit of 1 plus, which is 1, limit of 2 by n, limit of 2 by n as n tends to infinity is 0, therefore this limit is 1 by 1 into x, which is x. Now nature of the series, given series will be determined with respect to this x. That means what is the behavior of, looking at the behavior of this x, we will decide the nature of the series. That means by the D'Alembert's ratio test, given series sigma un is convergent when x is less than 1, because this limit value we got it as x. So as per the definition of D'Alembert's test, ratio test, we have it is convergent if limit is less than 1. That means here limit x is less than 1, and divergent if limit is greater than 1, that is x is greater than 1. And here this test fails in the D'Alembert's whenever x is equal to 1. This is what the explanation for this series to apply the D'Alembert's ratio test. Now let me go for next example. Problem 2. Test for convergence of the series 1 plus 2 factorial by 2 square plus 3 factorial by 3 cube plus 4 factorial by 4 power 4, etc. What will be the nth term of this series? Clearly n factorial divided by n power n. So sigma un is taken, whatever it is given, un is written n factorial by n power n. Therefore un plus 1 can be written. It is just enough to replace n by n plus 1 in un. So n plus 1 factorial divided by n plus 1 raised to n plus 1. Now un plus 1 divided by un is equal to, this numerator is un plus 1, this denominator is un. Now two ratios are multiplied, means denominator ratio we will take reciprocal and multiply. That is written here, n plus 1 factorial divided by n plus 1 power n plus 1 into n power n divided by n factorial. Look at the first numerator, that is n plus 1 factorial, which can be written 1 into 2 into 3 into etc. up to n into n plus 1. That means n factorial into n plus 1. So n factorial cancel with the denominator, that is second denominator n factorial. So remains n plus 1 in the numerator. So simplifying. Now after cancellation n factorial we get n plus 1 into n power n divided by this n plus 1 power n plus 1 splitted as n plus 1 power n into n plus 1, like using this property, that is we have a power m plus n can be written a power m into a power n. So the same property applied here. So we get this one. Now 1 n plus 1 in the numerator and denominator cancel, remaining n power n divided by n plus 1 power n. So from the denominator n plus 1 power n power n is taken out, remaining 1 plus 1 by n power n. So n power n cancel, remaining 1 by 1 plus n whole power n. This is what un plus 1 divided by un. Now applying the limit for un plus 1 divided by un as n tends to infinity, substitute. This is limit of numerator, that is limit of 1 is 1, limit of denominator, that is limit n tends to infinity, 1 plus 1 by n whole power n is e. We have a standard formula. So total limit is 1 by e. So we know that e equal to 2.7 something. So 1 by e is less than 1. So we conclude by D'Alembert's ratio test, given series Now go for next example. Check the nature of the series 1 by 2 power root n, 2 into root n plus x square by 3 into root 2 plus x power 4 by 4 into root 3 plus x power 6 in divided by 5 into root 4 plus etc. where x is greater than 0. So first we have to write nth term of a given series, that is un. Here for our convenience let us omit the first term. That is just for our convenience, even without omitting also, without neglecting first term also, you can directly write nth term, no issue. Here for time being, let me consider first term as x square by 3 power root 2, 3 into root 2. Second term as x power 4 by 4 into root 3. Third term as x power 6 by 5 root 4. It is just like taking a drop of water from a sea. It doesn't matter. So here sequence, the series is up to infinite terms. So if you take first term, if you neglect the first term, it doesn't matter here. It will not affect to the series. So no need to bother that we are going to omit the first term. That is just for our convenience. Without doing that also, you can solve or you can find the nature of the series. Time being, let me omit the first term and consider first term as I mentioned, x square by 3 root 2. Now to write the nth term, it seems simple here. First term numerator is x power 2. Second term numerator is x power 4. So clearly nth term numerator is x power 2n. First term denominator is 3 root 2. Second term denominator is 4 root 3. So clearly nth term denominator is n plus 2 root n plus 1. Therefore un plus 1 can be written, just replace n by n plus 1 in un expression. So we get un plus 1. Here this is un plus, just correct it. So un plus 1 equal to, this is un plus, this is un plus 1 equal to x power 2 of n plus 1 divided by n plus 3 root n plus 2. So we got un and un plus 1. Now dividing un plus 1 divided by un, we write x power 2 n plus 1 into n plus 1 divided by n plus 3 into root of n plus 2 into, because ratio is dividing, so we write multiplied by reciprocal of the denominator ratio. Here denominator ratio is un. So this is n plus 2 into root n plus 1 divided by x power 2n. Here first numerator, it is x power 2 of n plus 1, which means x power 2n plus 2. So x power 2n cancel with the second denominator, that is x power 2n, and rest x power 2 remains here, x power 2n into x power 2, therefore x power 2 remains. So we write n plus 2 into root n plus 1 divided by n plus 3 into root n plus 2 into x square. So we got what is un plus 1 divided by un. Now applying a limit as n tends to infinity, un plus 1 divided by un, which means limit n tends to infinity, I have substituted what we got for un plus 1 by un. And in previous un plus 1 by un, here just see n plus 2, if you take n outside, so it will become 1 plus 2 by n. In the second denominator, denominator, we have n plus 3. If you take n outside, this will be 1 plus 3 by n. Similarly, if you take from the root n inside the root, if you take n outside, this will be 1 plus 1 by n. In the denominator, if you take n outside inside the root, we get 1 plus 2 by n. So n, whatever we have taken n and root n from the numerator, that cancel with the denominator, we get this expression. Now applying the limit of 1 plus 2 by n. Here limit of 1 is 1, limit of 2 by n is 0. So 1 into limit of root of 1 plus 1 by n will be 1. Root 1, that is 1. Denominator limit also we get 1. So into x square. This will become x square. So this is equal to x square. So this limit we get it as equal to x square. Now we decide the nature of the series by defining this x square. So by given D'Alembert's test, series is convergent if x square is less than 1 and series is divergent if x square is greater than 1, and here test fails if x square equal to 1. So this is the way how to use the D'Alembert's ratio test. Now let me explain one more problem. Problem 4. Test for convergence of the series 1 plus 1 into 3 by 1 into 5 plus 1 into 3 into 5 divided by 1 into 5 into 9 plus 1 into 5 into 1 into 3 into 5 into 7 divided by 1 into 5 into 9 into 13 plus etc. Here nth term is not given, that we have to write. It is very easy. Look at the first term 1, second term 1 into 3 by 1 into 5, third term 1 into 3 into 5 divided by 1 into 5 into 9 etc. So in nth term 1 into 3 into 5 into 7 etc. expressions will be there. So to write the last term in nth term we use, see here, this is sigma un. Un we write it as 1 into 3 into 5 into 7 into etc. 2n minus 1. We get this last term by using the property of arithmetic progression, because here 1, 3, 5, 7 all are in arithmetic progression. That means, see here, 1, 3, 5 etc. These are in arithmetic progression. So nth term of given arithmetic progression Tn, nth term, we have a formula that is first term a plus n minus 1 into common ratio d. So common ratio is d here. So this is what we got. So here a is equal to 1. A is 1. So 1 plus n minus 1 into d. Common ratio is common difference, or not ratio. Common difference is 2. So into 2, if you simplify, we get this is 2n minus 1. This is what the nth term of the first numerator. So we write un equal to 1, 3, 5, 7 etc. 2n minus 1. Now denominator, it is also again arithmetic progression. So here also to find nth term we use the arithmetic progressions formula for nth term. We get 4n minus 3. Now similarly we write un plus 1, just replacing, it is just enough to replace n place by n plus 1. So we get last term as 2n plus 1 here in numerator, denominator 4n minus 1. Previous term should be 2n minus 1 in the numerator and 4n minus 3 in the denominator. Now un plus 1 divided by un, ratios are dividing means denominator ratio is multiplied by taking reciprocal. Here common factors are get cancelled. That means up to 1, 3, 5, 7 up to 2n minus 1. Second denominator what we have, cancel with first numerator. So 2n plus 1 remains. Similarly 1, 5, 9, 13 etc. up to 4n minus 3. What we have in the second numerator, cancel with same terms in the first denominator remains 4n minus 1. We get 2n plus 1 divided by 4n minus 1. Now, applying the limit as n tends to infinity, limit n tends to infinity, 2n plus 1 divided by 4n minus 1. Taking n outside, numerator and denominator get cancelled. We write limit n tends to infinity, 2 plus 1 by n divided by 4 minus 1 by n. So numerator limit is 2 plus 0, which is 2. Denominator limit is 4 minus 1 by n, which is 4. Which is 2 by 4, which is 1 by 2. So this is less than 1. Since this value limit is less than 1, we say by D'Alembert's ratio test, this series is convergent. This is the way how to find, how to check the nature of the series. This is all about the D'Alembert's ratio test.